Oh, it is recording. Right, I'm back. Right, have you this down? Or will I leave it there for a minute? Anyone? Out there?
Yeah, no, it's fine.
It's down? I can take it away?
Yeah.
Right, okay. Right, on to that, girls. This isn't a mandatory proof. The next small one isn't a mandatory proof, but it's you'll be asked non-mandatory proofs as well that you figure out yourself. So I'm just going to prove the area of a triangle, okay? So here's a triangle, capital A, small a, capital B, small b, capital C, small c, okay? Right, if I was to get the area of this triangle, right, okay, it'd be the half the base by the perpendicular height, okay? Half the base by the perpendicular height. So I'm going to draw in the perpendicular height and I'm going to call it h, okay? So the base is a, right, okay? So it's a half of a multiplied by the perpendicular height, I'm just going to call h, okay? But sine of b, right, in this little right angle triangle here, sine of b is opposite over our hypotenuse, which is h over c. So that means just cross multiplying there, you get h is equal to c by sine b. Right, so up here, so the area was a half a by h. Instead of h, I'm going to write in c sine b. So area equals a half a multiplied by c sine b, which is a half a c sine b. Okay, that's all that is. Okay, so I'll just give you a sec to write that down. Ready? Right, the next thing which is mandatory is the cosine rule. Okay, remember the cosine.
Should we go back?
Yeah, well, you can let me know when you're ready.
Yeah, I'm ready now, sorry.
Right, everyone okay? Right, okay, so remember the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So that's what we're trying to prove. Okay, so what we do is we draw an axis, x and y axis. We draw a at 0, 0, we make it obtuse, right? Okay, so capital A, small a, capital B, small b, capital C, small c, right? Okay, so I've drawn it on the x and y axis, okay, right? And so the coordinates at this point out here would be c, 0. So it'd be across c, up 0. The coordinates at that point there, okay? Now, to get the coordinates at this point over here, I'm going to draw a circle with radius b. So that's a circle of radius b. Okay, I'm going to draw down here now, don't draw this bit. Okay, remember when we had the unit circle? So the unit circle had a radius of 1, right? Each, the coordinate of any point on the circle was cos A sine A, wasn't it? They were the coordinates of any circle on the unit circle. This isn't the unit circle now, this has a radius of b, so it doesn't have a radius of 1, but the coordinates, girls, are right. Okay, if the radius was 2, it would be 2 cos A, 2 sine B, 2 sine A, 2 cos A, 2 sine A. If it was, if it had a radius of 3, it'd be 3 cos A, 3 sine B. Okay, is that alright? So whatever the radius is, that's what the coordinates are. So over here, the coordinates at this point here would be b cos A, b sin A. So the coordinates at that point there. Okay? Right, so for my proof, I'm going to get the distance from C to B. So capital C to capital B. So from this angle here over to this angle here. I'm going to get the length of that line, which I called A. So I'm going to get the length of A. So I'm going to use the distance formula. So the length of A, right, small a, would be the square root of, I'll just write down the formula first, x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so this is the first point, b cos A, b sin A. Right, and the second point is over here, which is C0. So I call this one x1, y1, x2, y2. Right, and I'll fill in into my formula. So A is equal to the square root of x2 is b sin A. Sorry, just because I called it x2, can I change just the labels to make one x1, y1, x2, x1, y1, x2, y2. It actually doesn't matter, but it's just, I have it written in and I'm too lazy to write it out again. So it's b cos A, b sin A minus c. So x2 minus x1 to be squared plus y2, which is b sin A, minus y1 to be squared, which was 0 to be squared. Okay, so next step.
This should not be b cos A for the first.
It should be, sorry, yes it should, thank you. That should be b cos A. So it's x2 minus x1 plus y2 minus y1 to be squared. Right? As I say, it doesn't matter which one you're putting first because you're going to square them anyway. Okay, so right, so now I'm going to square out those brackets. So A is equal to the square root of, right, square the first, so that would be b squared times cos squared A. Square the first, twice the first by the second, which would be 2bc cos A. Square the last, plus c squared. Right, here it's b sin A minus 0, which is just b sin A, so I just have to square b squared sin squared A. And there's big square root sign across the top of that. It's gone off the page of me, sorry. Okay, next thing I'm going to do is I'm going to get rid of that square sign by squaring both sides. Right? So I'm going to square both sides. B squared cos squared A minus 2bc cos A plus c squared plus b squared sin squared A. Now, see the way there's a b squared and a b squared common here, so I'm going to put these two terms beside each other. So I'm going to go a squared equals b squared, just writing it in a different order, cos squared A. Then I'm going to write this one next, plus b squared sin squared A Then I'm going to put this one next, plus c squared minus 2bc cos A. So I've just written the exact same thing, I've just written everything in a different order. Okay? Now, here out of these two, there's a b squared common, so I'm taking out the b squared. So it's b squared into cos squared A plus sine squared A. Someone lost the will to live there. Right, plus c squared minus 2bc cos A. Okay girls, we've learned from trick 2 that cos squared A plus sine squared A, it's in our formula table, adds to 1. So that's 1. So that means A squared is equal to B squared multiplied by 1 plus C squared minus 2BC cos A, which is our cosine rule proved. So A squared equals B squared plus C squared minus 2bc cos A, and that's the cosine rule proved. Okay? Sorry, I'd like to move it up a bit. Why won't that move? No. Right. Okay, and I'll just move that up a small bit. That's cosine rule proved. Okay, so all it was once you get the circle set up, all it is the distance formula. So setting up the circle, right, is the kind of bit you have to remember, and then it's just a distance formula and squaring it out. Okay, right, can I take it away, or anyone say no? I've taken it away, so scream again. Okay, right, the next thing I want to do is, when we were doing algebra 3, girls, right, okay, which is near the end of the book, we didn't do induction. Okay, so induction, it's proof by induction, and there is proofs by induction. There's 3 types. Okay, so there's a series of numbers, there's factors of expressions, right, and ones involving inequalities. Okay, so I'm going to do the series of numbers today. Right, now this is a bit out there when you start with, okay, right, but after a while it just becomes second nature, and you know, it's actually quite doable when you kind of get into it. Okay, so prepare to be stunned for the first 20 minutes, but it'll be fine after that. Okay, right, so I'm going to prove results involving series of numbers. So I'm doing this one today, I'm doing factors of expressions tomorrow, and I'm doing inequalities on Thursday, and I'll probably fit in De Moivre's here and there at some stage as well. Okay, so that's my plan, right, for the rest of the week. Okay, so here we go. This is going to mean absolutely nothing to you, right, until we actually do one. Okay, but these are the steps involved, so you might jot these down and put a box around them, because this is what you'll be using for the next 3 days. Okay, so proof by induction, the steps involved, right? Okay, so you have to prove the statement is true for n equals 1. Then you assume the statement is true for n equals k. You prove the statement is true for n equals k plus 1, and then you make a conclusion. right? And this is always your conclusion. You say, well, it's true for n equals 1, it's true for n equals k, it's true for n equals k plus 1, therefore it's true for all n. Okay, so this is the last 4 lines in every sum, right, for the week. Okay, so this is the last 4 lines in every sum for the week. You say, well, it's true for n equals 1, it's true for n equals k, it's true for n equals k plus 1, so it's true for all n. Right, okay, so as I say, jot it down, right, it'll mean nothing until we actually do one, so.
Miss, can you move it to the left a small bit?
Left.
Oh, actually, no, mine's going to have it.
Are you okay? Oh, I know, the pictures of the people were on top of it, was it?
I was zoomed in, that's why I thought I couldn't see it.
Alright, okay, we're okay. That says for all n. Right, am I good? Say no if I'm not.
No.
Okay. Are you all still in your jammies? Is that why no one puts on the cameras, yeah? Some of you are probably lying in the bed, are you? Be honest.
No, I just look too tired. Yeah, same.
Yeah, me too, but I put it on anyway. Right, are we okay? Can I take it away?
Yeah.
Right, okay, we're good? Right, here's an example. Right, so this is the results involving a series of numbers. This is the first type of one you may be asked to do. Right, okay? So, as I say, it'll sound like double Dutch for the first few, but after that you'll get into it, okay? Right, so results involving a series of numbers. So, example 1, prove that for all values of n, that if you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus all the way up to whatever n is, it's the same as if you take n over 2, right, and you multiply it by n plus 1, that'll get you the same answer. Okay, so please remember, guys, right, you know the way all the numbers here, 1 plus 2 plus 3 plus, I'm saying all the way up to n, what would be after n? What's the next one after n?
N plus 1.
N plus 1, very good. And what would be the next one after that? N plus 2, wouldn't it? And so on. You don't need that, but it might be useful in a minute, okay? Right? So they go all the way up to n, and then they go n plus 1 is after that, etc. Right? Okay. So, and you need to prove it's true for n equals 1. Prove it's true for n equals 1. Remember, n stands for the numbers, the position of the term. So n equals 1 is just take the first term. So the first term is 1, isn't it? So n equals 1 is just the first term on the left hand side. And on the right hand side, everywhere you see an n, stick in a 1. So it's 1 over 2 times 1 plus 1. So that means 1 is equal to a half of 2 is 1. So that is true for n equals 1. Okay? So step 1, prove is true for n equals 1. N is the number of the term from sequences and series and stuff, the number of the term. So n equals 1 is just the first term. So does the first term on the left equal to, just fill in n, 1 for n over there, and yes it does. You end up with 1 equals 1. Okay? The next step is assume it's true for n equals k. Right, okay, so that means 1 plus 2 plus 3 all the way up to k. So just instead of n I'm writing k, right, equals over here instead of n I'm writing k over 2 times k plus 1. Okay? So, as far as I'm concerned, that statement there is true. Okay? That's going to be, when I get to my proof, that's going to be the first line of the proof. Okay? So, I've assumed this is true, so I'm taking this as true from now on. And you know, when you're doing a proof, you always start with a true statement. This is going to be the true statement I'm starting with. Right? Okay. Right? Then, I need to prove it's true for n equals k plus 1. So, the next step is prove it's true for n equals k plus 1. Right? So that means I'm trying to prove, right, this is what I'm trying to prove. Okay? So I'm trying to prove that 1 plus 2 plus 3 plus all the way up to k plus the next term up, k plus 1. Okay, so k is this term, k plus 1 is the next term. So here all the way up to k and then the next term beyond it is equal to, but this time everywhere I see an n I'm putting in a k plus 1. So equals k plus 1 over 2 times k plus 1, because instead of k I'm writing k plus 1 plus 1. Right? Okay, and that would be k plus 1 over 2 times k plus 2. Okay, so this is what I'm trying to prove. This line here, see this my to prove line? That would be my last line, right? Okay, of my proof. Okay? So now I've proved nothing yet, I've only talked about what I'm going to prove. So now I have to do the proof. Okay, and you always start a proof with a true statement. So the only true statement I know is here. I assumed it's true, but I'm taking that as true, right? So the proof 1 plus 2 plus 3 plus all the way up to k is equal to k over 2 times k plus 1. Okay, this is my true statement. I need to turn this statement here into this statement here. Okay, so I'm starting with what's true. You always start to prove with a true statement. So I'm starting with a true statement, and I need to turn my true statement into what I'm trying to prove. Okay, so I need to turn this into this. Okay, so you look and you say, well look, this is the same, but there's an extra k plus 1. And over here I'll worry about in a minute. So I'm just looking at the left hand side, right? Okay, so I think if I add a k plus 1 to both sides, remember with an equation you can do what you want to it as long as you do it to both sides. So I've decided I'm going to add a k plus 1 to both sides. So on the left hand side I have 1 plus 2 plus 3, sorry I need to move up. Have I cut anyone off? 1 plus 2 plus 3 plus all the way up to k, but I'm going to add a k plus 1 into this side, right? equals k over 2 times k plus 1 plus k plus 1. Okay, so I've added a k plus 1 to both sides. Now my left hand side looks the way I want it to look. My right hand side, not so much. Right, okay, so what I've got to do is I have to play around with the right hand side to make it look like what I want it to look like. Because this is what I want. Right, I want this to be my last line. So I need to, the left hand side is the same. I need to play around with the right hand side to make it look like this. Okay, so we get 1 plus 2 plus 3 dot 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 plus k plus 1 equals, now I'm going to play around with this. The easiest way to play around with this is to multiply into the brackets and see where I go then. So that would be k squared over 2 plus k over 2 plus k plus 1. Is that okay? Now, I'm going to get a common denominator. So 1 plus 2 plus 3 plus k plus 1, which is what I want it to be. Right, I'm going to get a common denominator. There is a shorter way, but I'm just thinking the easiest way to see would be just get a common denominator. So I have k squared plus k plus 2k plus 1. Okay, then I have 1 plus 2 plus 3 plus k plus 1 equals, on top I have k squared plus 3k plus 1 all over 2. Is that okay? Nearly done. I need another board and I need a duster. Sorry. Okay, so what I can do is factorize on top of the line. Okay, because look what I want to turn it into, a k plus 1 and a k plus 2. Right, I have done something